All right, so here's the problem. We got Elijah, and he's shooting a high-powered rifle that shoots with a velocity v initial at some angle theta, say 30 degrees or 25 degrees or whatever. No, don't write down what angle it is.
Okay.
I specifically am leaving it as theta. Okay.
Okay.
You're shooting it from a height 1. This could be from 6 feet off the ground. Height 1, right? And that would actually make sense because, if you're shooting it from up here, well, I don't know if you're 6 feet from shoulder down, but, let's say 5 feet or something like that. That would make sense, right?
Yeah.
Or, actually, if you're shooting up, then the barrel is technically like 6 feet off the ground. Okay, fine. So that height, we can vary that. We can change this, right? And then this height could be something different, too. The reason why I'm using general, letters instead of numbers, here's the big advantage, is because if we figure out the equation, this equation will apply to any situation.
You can plug in the numbers.
We can just change the numbers.
Oh, that's awesome.
Right? If we're talking about a shorter person, we could just change H1 to be a different number.
Yeah.
And we're talking about this thing being on top of the cliff versus being down in a valley. If it's down in a valley, we'll just make H2 smaller than H1, or just make it negative.
Yeah.
Right?
Yeah.
And you're shooting down.
I just want to make sure that it's
Cool.
You got it?
Yep.
So, and we can even say, well, what about the different, guns and stuff like that?
And then just change the velocity initial.
Change the velocity of your gun. Cool. This is the problem that we solved in lab.
Yeah.
The only difference is H2 was 0.
Yeah. Because we were shooting down. Or no. Ground is never mind.
Yeah, but this is the problem we solved in lab. And by the way, in lab, this is super.
It was cool.
What we did was we figured out the velocity of our cannon. We had a little cannon. We figured out the velocity of our cannon. And then once we got the velocity of our cannon, we said, okay, now if I set this thing to a certain height and a certain angle, and we know the velocity, Elijah was able to put army men on the ground,
Wait, so you
some
actually did
distance
the
away.
argument thing?
Yeah, and then he shot it and was able to hit it first try.
Yeah, that was really cool. We sniped 2 guys.
Yeah, just boom, hit him perfectly.
And then after that, never
Yeah.
hit another guy.
Well, no, but it's because you line them up all horizontally, and this is what I'm thinking is you line them up all horizontally. But if you looked at our error bars on our
It was-
shots,
yeah.
it had about this. So if they were clustered,
It had a spread.
and then what you should do is if you were actually firing a cannon like back in the colonial days, you should fire short because the
Oh,
thing bounces, and kills lots of people that way. So.
that's correct. That is the tactic they did.
No, yeah. If you watched, I think it was The Patriot. Is that what the Mel Gibson one? I don't know.
think
That
so.
might be too old for you guys. You watch them, and they're like, the way that the cannonball kills lots of people
Is its bounce?
is it hits the ground and just boom, boom, and it just
So much.
yeah.
Wait till you see the grape shot. That was basically the first ever shotgun.
All right. Anyway, you ready?
Yeah.
All right, man up.
Oh,
So live.
Because after you solve this, I'm gonna
You get to
work
solve
with you
every
to-
problem after.
and then we'll blow your mind. It will be another one of those days where I'm going to just blow your mind.
completely destroy everything I know. Okay.
No, not destroy. Solidify everything you know. Make you realize you didn't even know everything you know.
So, doing 2-dimensional.
Okay. So you're putting notes up as far as what is I'm doing. All right. Before I start the problem, what I would do is first I would set a coordinate system.
Oh, the triangle thing.
No, which way is positive? Is it up positive? Is down positive? Is forward positive? Is backwards positive? What do you want?
A graph.
Wait, graph.
Yeah, I usually
Like
make
a
it like
normal
this.
graph.
I usually make it like this, and just to remind myself.
Oh.
Positive X, positive Y.
Okay, cool.
We can call up positive. That's fine.
From this point or from that point? Usually from the point of the gun, right?
Well, no. I like what you're saying. Are you saying is 0 here or 0 here?
Right. Because then, if what you said about the valley being down here, then 0 would actually be there. So
Mm.
we're shooting down. This.
Yeah, but in this case, we are putting 0 here
Okay.
because we're talking about the height of the,
Total
this-
height.
Does that make sense?
Including the person
Yes.
standing.
Okay, go. And we're calling everything going up positive, and everything going to the right positive.
So right now I'm just solving the equation, correct?
Yes.
So first thing I need to find is velocity.
Okay, wait. Before I'll ever start problems, if I see a vector that has an angle, we can use Emma's help here.
It's not.
What are we finding? Question.
Oh, there we go. And then that V naught sine theta, that's actually V naught x, right?
Yes.
That's the x component of V naught, which is equal to V naught sine theta, right?
Right. Oh, I forgot this.
No. You actually need it here.
Instead of putting theta.
V naught x is equal to V naught sine theta.
Oh, okay. Let me fix that.
I could either write V naught x, which is just saying the x component of this vector, or I can write V naught sine theta. It's the same thing. Cameron, you confused where that comes from? It comes from SOHCAHTOA.
It's basic.
Here, I'll show you. It's really
Not
easy.
too hard.
Sine of theta is opposite over hypotenuse,
It's the whole it
right?
spell out
So this is
Yeah,
V naught,
so
and this is theta.
now,
COH.
Then sine of theta is equal to this thing divided by V naught.
Hello, partner.
Does that make sense? So V naught sine theta is equal to what my question mark is. That's why he has a V naught sine theta there.
Okay, so I'm gonna solve delta
And he didn't
x.
write question mark, he wrote V naught x. That's the only difference.
So,
Alright.
I'd want to find the velocity initial first, or whatever.
I think you're going. We've done the same steps for almost all of these problems that have to do with projectile motion. First step, solve for the time in the y direction.
Because you're looking
When I use
for
the
the
velocity
range.
initial.
Yes, you would need the velocity initial time. We do know. All right, so the first glasses we're going to put on is the y direction glasses.
Right.
Right, so maybe label that up at top. Here, you can give reasons. He's nervous, folks.
Very, very
You
nervous.
can do it, Elijah.
Elijah, there's no other physics students here except for you.
Yeah, you're like
It's
the old
recorded
man
though,
fishing.
so that means next year's physics students can watch it because I found all the old videos.
Yeah, I've seen all your old algebra
Yeah,
videos.
I found
too.
the old math video with me
Alright.
in it.
Delta y, so my,
We're trying to find time.
good. My v final is your dk dc, you already knew that.
Yeah.
Good, I like it.
We don't know this. Or we don't know anything. So how do I even go about it? But I can do
Set up
this
the
first.
equation.
We know v naught in the y direction, because we're talking about y direction, right? It's this. Actually, this is v naught y, this is v naught x.
I thought something was a little off.
Is v naught y is v naught sine theta, so we should write that there. Cool.
This
We
is
know
the
A.
equation we're using. We do?
In
Oh,
the y
9.81.
direction?
9.81. Negative 9.81.
Negative g, just put g.
Right. Don't put numbers yet. Equation.
You just have to set up the equation first.
Okay.
And then you
And then the delta y. What is the final height?
Height 2.
What is the initial height? So delta y is height 2 minus height 1. h2 minus h1.
Oh, cool.
That's it.
Oh, that's I. That's also I.
You could put hf minus hi, and that would be height final minus height initial. And
But since we
Same
have
thing.
numbers,
Yeah, but since the numbers, it's
Yeah, right,
it's
fine.
a little
Easier.
confusing.
Okay.
Oh, then we're
So now
using
you
this-
have it.
And we're using this equation.
Yup.
Perfect.
He calls it Pervner
You
because.
barely touched upon Pervner. You have no right to talk about Pervner.
Silence.
Oh yeah,
You have no place to talk about
They-
Pervner.
they Pervnerded it out, my friend.
You have no place to talk about silence.
They're definitely Pervnerds.
Okay. How would I? Hello? Hello? Hello?
Yes, hello, Spectrum.
Okay, bye. I don't have any zeros, do I? Do
No,
I?
you don't.
Right.
I'll help you through this part. This is tough.
So I'm trying to change it for
So your delta, this is just h2 minus h1.
Oh, and should I plug in all of these first then?
Yep.
Okay. So then this is
T.
This P is mine? No, because we're going.
All right, do me a favor.
Okay.
Just move to the side just a little bit, so your people can see.
Oh,
Right.
Sorry.
People don't like it when I talk physically this. Okay. I always make my T's with a little hook on the bottom.
Okay.
Because I can imagine people getting confused with your T and getting a plus.
Yeah.
Don't, when you plug in the negative G for A, don't do it like this. You might want to do it like this. Because when you plug it in like this looks like 1/2 minus G.
Oh.
Totally different.
Oh, the algebra.
Or maybe what you can do is you just change that to negative 1/2 GT squared.
Oh.
Right? Because it's 1/2
Yeah.
times negative G, which makes it negative 1/2 GT squared.
Oh, okay.
Make sense?
Yes.
Okay, good. You know how to solve that?
So for T only, I would guess I have to.
This is where I'm going to step in and just be like, well, let me hold your hand. All I did was I took everything over on the right side and put it on the left side. Okay, do you know how to solve that?
Maybe. Question: how'd you get this plus sign? Is it because this is positive?
Well, yeah,
Because you're
it's
adding
just
everything
H.
to
I just
the-
added everything to that side, so it's
Oh, okay. I
Because
see.
it's
It's
not
still there.
negative.
How do I get T on that side? Would I just divide this by T?
Nope. Do you know how to solve it? You probably don't recognize it in this form.
Oh, is this
Would you add
is this
the
what I think it
V naught
is?
Sine
What's it called?
T
Go.
plus
x squared plus x, or no, ax squared plus bx plus c? Is that what that is? Hold on. Son of a gun.
Zero.
Son of a gun.
So, there's this boy. Kind of a negative guy.
Yes, he is. Yes, he is.
He was unsure about going to this radical party.
Oh, it's so radical.
Yeah. He was kind of a square at the party.
Yeah, he was.
Missed out on talking to 4 awesome chicks.
They were pretty awesome.
Party was over at 2 a.m.
Negative. Oh, it is? No.
So let me tell you about this boy, okay? Alright, so in this case, B is negative V naught sine theta.
So he changed.
Yes.
This is where it's going to get funky. But all I'm doing is I'm taking this, and I said, okay, fine. Here, maybe stand over here so they can see too. A is equal to 1/2 G. Cool?
Yeah.
B is equal to negative V naught sine theta. We cool?
Yeah.
And C is all that junk left over, H2 minus H1.
You're just gonna plug it into the quadratic.
All I'm going to do is just plug that there and then take that there and put it there. It's going to look ugly. So, I don't care about ugly.
It's a bazooka.
All right.
It's supposed to be ugly.
Negative B is actually just V naught sine theta. Plus or minus the square root of that thing squared is V naught squared sine squared theta.
Why is it squared? Oh,
Right? Because it's
Oh, because you have different values.
V naught sine theta squared
it's just yeah.
is V naught squared and sine
Because
theta
it's
squared.
different values for each.
Yeah. Okay? And then minus 4 times 1/2 G times C, so H2 minus H1. Well, 4 times 1/2 is 2, so I'm just going to put it to 2. Is that all right with you?
Yeah. That gets one less.
Close
letter.
parentheses, divide that by,
2a. So that's
So G.
just G. Yeah.
right, because 2 times 1/2 G is G. We cool?
Okay.
And this is equal to T, because we solved for
T.
T. I know it looks like we solved for X, but we didn't solve for X. It's just our quadratic equation just happened to have a T instead of an X.
Oh, that's so.
Wait, how did you get
I like
to
math
the
now.
negative V naught sine? Because isn't it negative 1/2 GT?
Because that.
No, but how the heck did that get over there when it's...
How did what get where? Yeah, let's do it. Let's do it. Let's argue. Go.
Okay. Because you start the problem
Oi.
here, looking for t,
Yes.
and this is the negative one. How did this become negative?
Okay, here. How did I bring this to that side?
Because I
added
saw that.
1/2 gt squared to that side.
And then you subtract v sine.
I subtracted v naught sine theta to that side. Okay, fine. Here.
Okay, wait.
5
Hold on.
equals negative, or 5 equals 3x minus 5x squared. Okay, you ready? Add 5x squared to both sides.
Hold on.
That kills that.
Yeah.
Subtract 3x from both sides.
What's that?
That kills that. So on the right hand side I have 0, and on the left hand side I have 5x squared minus 3x plus 5.
But why do that when you can just subtract the 5 from both sides?
I could have done that, totally.
Yeah, could have done that. But
Algebra is just like it's like you, if this were
Then you change the equation.
No,
you just like move this whole equation.
This is
you
good, this is
subtract
good.
This whole thing, and wouldn't this still be a negative?
No, I just.
Because if you're moving it over, you're subtracting this, but this is a whole different. It's a full equation, as it's, and you're moving it. You're
There's
not moving
two
it piece by
separate
piece.
terms here.
Yeah, but
I am moving it piece by piece.
oh.
he just skipped that step.
I'm sorry, yeah, you're right. I am moving it piece by piece. I just did both pieces at the same time.
Damn, Mr. Darling, mental math.
I'm good at algebra.
He's
You're
really
just
good.
good at all that. It's
Oh, sorry.
confusing.
Why do that? Doesn't
When you
it-
could have just taken this over to that side?
Yeah.
Yeah.
Yeah, I agree with you.
That makes
The thing is,
Oh yeah, why couldn't?
Plus, then you
no,
keep it all.
no, you're absolutely right. You're absolutely right. Fine. We could have done this. Watch. We could have gone. Would it be right with you if I just did this negative 1/2 gt squared plus v naught sine theta minus h2 plus h1 equals 0? This, what you're suggesting is you took the h2 h1 and put it on the other side, but you kept this over here. And oh, I'm sorry, there's a t here. And the only thing I changed here was I wrote the t squared first, and then this one with the t in it.
It's the same.
That's what you're suggesting?
Yeah, because that's a nice.
I'm
The
completely
equation
fine with
is
that.
Different though.
Huh?
Isn't the equation different though?
No,
No, it's
this
still
is
the
the same.
It's still the same
The
because
one
you're
He's
just
talking about the
changing
signs, the plus and
Oh,
signs.
okay,
This
yeah,
is-
fine. Here, watch. Okay, ready? I could plug this into the quadratic equation, and it would come out to be the same exact thing.
Yeah, because it's the same. It's the same. Plus,
It's
this
just backwards.
this looks more like that's nice. It looks nicer that way.
I chose to make my first term a positive number. That's why. Watch this. I'm allowed to multiply both sides by -1, right? There's nothing wrong with that, right? What's 0 times -1?
0.
And then I basically just change the sign on all of these. 1/2 gt squared minus v naught sine theta
Oh, I thought you said you had to go.
You just change all
plus
the signs.
h2 minus h1.
Oh, is that
We have
minus
signs
that
of the
thing right
T.
there?
That's exactly that. It's the same equation. Oh, you're right.
You know how many umbrellas
Forget the T.
All right.
Is that basically the same as these two signs right there?
Yeah,
Well,
it's the same
Look, this is the same thing as that, and I plug that into here. So if I do that
All
into
the
there,
same
it's
thing.
the same thing.
thing.
It's the same goat.
So
Still
then-
shooting the same goat.
The same
I think the
chemical.
reason being is because it's equal to 0, and that's kind of like why I can just
Do it.
almost disregard these negatives.
0 is just such a nice value to work with.
Right, because it's like the great annihilator, right?
It kills everything.
I multiplied both sides by -1. Sure, I can mess with that side on the other side as much as I want because you're going to multiply that by 0.
Yeah, it's still 0.
Still 0. Does that make sense?
I like 0 in physics
Okay.
equations too.
0 is
So here's your time.
Oh,
This is actually a time. If you plugged in the numbers, you would get some number, like 5 or 3 or something, or probably some decimal. If you plug your velocity initial, your sign, this all in here, this represents just a straight up number.
Okay.
Got it?
That represents time.
Okay. So tell me how far you went. We've had our y axis velocity.
Now it's x-axis.
Now we're going to look in the x direction.
So
We'll do it over here, probably. I drew the picture so darn big that
I know.
there's
we don't have any
It's
space
just
for it.
huge. Yeah, just do it inside the picture.
No. It's good.
It's we're gonna use that later.
Or no, actually,
It just looks like you could just solve this with trig. It's all angles. Just use Silvertop.
The problem is,
It
I
looks
think
like
that
you
what
could
you're
do
trying to do
that.
is you're trying to solve it with trig, and that would be true if all this stuff were straight lines.
Yeah.
But
But you have
Gravity
curves,
did not
graphs.
exist.
So we
Yeah,
know
gravity
The
didn't
gravity
exist.
Right.
was perfect.
But the problem is,
Yeah.
in physics, everything's curved because
Physics,
there's
why you gotta be
gravity.
different?
gravity is.
Hey, but if we're doing this in space, it would have gone straight.
Exactly. And there would have
Yeah,
been no
well,
noise.
We're not in space. We're on Earth.
Yeah.
Well, technically we're in
Wait.
space because
No,
Earth is in
because we're still on
space,
Earth.
but
Yeah. So does that mean astrophysicists, the guys who deal with the physics of space, don't actually have to learn this stuff?
They don't have to learn physics.
now they probably still have to learn physics,
Just
but they
learn
just
trig.
don't care.
No, actually, they have to learn this stuff, but they actually have to deal with a math that is actually.
Yeah, way harder.
I learned it 2 years ago, and I've been studying physics for almost 20 years.
Oh wow. Okay. Can I just plug this into there?
If it was space,
Just-
what? I'm sorry.
No, go
Wait,
But
there.
if it was space, wouldn't this technically be just like flipped upside down? Because
can't
there's
really,
no gravity, you can't go in a
Right.
straight line. You can. It's gonna take you out.
There's no up or down in
There's
space.
no,
There's no direction.
there's no
in space.
acceleration. It would actually, just, if these were lasers, this would go straight. You wouldn't have to take into account. Stormtroopers don't actually have to take into account the bullet dropping,
Which is why they miss all the time, I think.
which is why they missed because they would probably practice using guns.
There's just there's just no physics for
For the helmet's
stormtrooper
like that's
aim.
not. There's no window. It's just.
stormtrooper aim.
It's really just blacked out.
All right, anyway.
So can I just plug this into there?
just you
Yeah, just
point
say
an arrow
T is
to
T.
it.
Yeah, I would just put it.
Point an
oil.
arrow to
Yeah.
it.
That's what
There's
I
no
would do.
point in writing all that again.
Well, no, that's what I was asking. Can I just plug this into there?
Yep.
And then I'm trying to find.
Well, yeah, because that's our
What is your
time.
acceleration in?
Oh,
In the
wait,
X
no,
direction.
it's not 9.81 because we're not going down, we're going straight. So wouldn't it just be 0? Would it be 0?
Would it be 0?
Yeah.
Your acceleration in the X direction?
Wait,
Because it,
wait.
it has that face of it's a trick question. Or
I always have that face as a trick question.
Because Mr. Dalday always puts a trick question.
then.
Exactly. We're learning your
So-
tricks, Mr. Dalday.
wait, because our acceleration is gravity, but that's going down. So
Yes.
we're going this, so then this would just be 0.
I agree.
Yeah, because we're going.
Have
Right.
confidence in your answer, my friend.
Believe in
I
yourself.
don't-
Believe in yourself.
I'm in front of Mr. Dalday. Of course, I'm not confident.
But you're in front of your peers as well.
Terrible.
Yeah,
I
that
do
is
this
terrible.
to make you confident.
Exactly.
After you just said what you do to Sam. Purposely. Oh wait, no, that's uncomfortable. Not.
Yeah, not
No,
on-
no,
not
I make you uncomfortable to make you confident.
Exactly.
I want you to say it's 0, and if you're wrong, then I'll tell you you're wrong.
It's
Tough
like-
love, my friend.
It's like theater. You just do it and then
Oh
you
wait,
do
we're
it.
not trying to find. Are we trying to find velocity?
No, we know the velocity inertia.
Yeah.
No pain, no
V sine
gain.
theta.
V cosine theta.
Oh right.
V not cosine theta.
Wow. Okay, since I watched that.
Bye-bye.
And what is delta x?
Trying to find.
R,
Oh.
which is what we're trying to find. You're right.
Literally since I started
Could have
Later.
left the
All right.
questions.
Equation.
We're trying to find R. We are also using pervert.
Don't even talk about curve nerd.
You know what? He's doing a hard version of perv nerd with this delta x equals v naught t plus 1 half a
Yeah, but
squared.
with the amount of times you made us do perv nerd and how
I'm gonna make
much
him do.
I've done this
Delta
equation like
X.
7 times already.
I'm gonna
today.
make him
do I have to show you my notebook again?
I'm gonna make him
of
do
perv
delta
nerd?
x equals v naught t plus 1 half a t squared as many times as I made you do perv nerd.
Good.
And then I'm just gonna make that curve
Good.
to represent that.
Suffer.
He will learn to hate an equation just like you did.
Oh wait.
Gone.
Good.
Acceleration 0.
Absolutely.
Oh, sweet.
So,
So I just gotta find the cosine and then multiply times. And
well,
I
no,
get the range.
yeah. So basically, your range is what?
So that should work.
Oh, the cosine.
And I know Brennan.
You know
Really?
cosine times 9. Wait.
So
Yeah, so
Confidence, Elijah.
v naught cosine times that. Write it out at least once.
You not cosine. Oh jeez.
It looks great.
I can write it for you. I have tiny handwriting.
This is how you pick up chicks at Starbucks,
No, it's not. It's how you intimidate everyone in there.
Exactly.
right? Like if you're writing this stuff down,
don't know if I'm writing this.
And then you like write down your answer and box it, and it's like this long.
They're just like,
Nah,
all day.
I'd just be like,
I'm sorry, that was a lie. Physics doesn't pick up chicks.
It's the jocks. It's the
No.
jocks.
it's not even the jocks. Nobody picks up anybody at Starbucks because it's Starbucks.
The hipsters.
Well, they're hipsters. They don't follow the rules
Exactly.
because that's too mainstream. Oh snap!
Does it automatically log you off?
It'll request.
Am I doing this right?
Oh, okay, okay.
2, 3, each. One.
You can
Yeah,
erase
not
that
like
arrow.
this.
You know.
You need a.
Power.
Let's erase this
Power.
arrow. You need a
We've
parentheses
established
right here.
we've established that that's what
You
T
need to
is.
close this thing off. Alright, and then you divide that by G. Good.
Wow, that is a very large equation.
Good, you manned up and you did it. Alright, I'm going to
Yay.
erase this part if that's alright. I'll erase this half of the board. We have our answer.
Okay, cool.
Is that alright?
Yes.
Okay, so this is
You have it on
the
record.
form, which means, sorry.
So
Awesome.
you can go back.
Just in
and
case you
Which means there
didn't take
is-
notes on it, which you did.
I did not.
So that means
Okay.
Because I wrote it.
Which is
Okay, so
watch.
check it
Goodbye,
out.
chubby goat.
So that means that the
So,
brass
let-
has to be close to
Here,
the
you sit down
circuit.
now, and I'll take
The
it.
battery's getting
I stole your
charged. But for whatever reason, it's not transmitting the current to the bulb.
Let's check the units.
It stops at the brass.
Ooh, I love doing that.
Stopping at
Units should work.
the brass.
Excuse me.
Alright. What's the units of
Figure out why
V
that
naught?
hurts.
Meters over second.
Okay. What's the units of cosine theta?
Well, the new form too.
Oh.
I think
Does
so,
it
yeah.
have?
There is a
Yeah.
So that
It's
means
just
that
an
it
angle.
is
Yeah.
It's an angle.
Yeah.
Which isn't like any units at all.
one,
Yes.
What's the units of
yeah.
V naught again?
Meters over second.
Meters over second. So we're multiplying this, by the way.
Yes.
What's the units of sine theta?
Nothing. It's a number.
So I still have the plus or minus, right?
Yes.
What's the units of V naught squared?
Meters over second. Both
Squared.
of them squared.
Squared per second squared.
Yeah.
Sine theta squared?
Oh, wait.
Nothing.
Nothing. Minus 2?
Nothing.
Well, the minus is there, but the 2's not.
Yeah.
What about G?
Meters per second squared.
What about H?
Meters, because we're measuring it in meters, I assume.
What about H1?
Also meters, because
So what is meters minus meters?
nothing. It's gone.
No, it's meters.
Oh,
Yeah.
really? Oh, okay. They don't cancel. Oh,
No,
No,
remember, like, if
You
this
have
were
to-
like 20 feet and this were 10 feet, then your
They
20
don't
feet
cancel
minus 10
out.
feet is
still feet.
10
still
feet.
measured in feet.
Right. Okay. Okay.
Does that make sense?
That makes a
Still
lot of
10
sense.
feet.
Alright, so
Okay.
I'm just going to put meters up here.
Tomorrow.
Cool?
Right.
Divide that whole thing by meters per second squared because that's the gravity.
Yes.
Alright, so this is, I'm gonna do a lot of chalkboard math here. This is meters squared per second squared, cool?
Because you add the meters to the
Yes.
Alright, now
Yes.
here's a trick question. What is a meter squared per second squared minus a meter squared per second squared?
meters squared per second
Squared?
squared.
It's a
Oh.
meter squared per second squared, right?
Woo!
Can you explain why?
Because it's the same
It's
freaking
the
thing.
same thing.
Oh.
If I
You're
have
combining
20
like
feet minus
terms.
5 feet, I've still got, if I subtract those two.
Okay.
You still
Remember,
have
I'm looking
feet.
at the units.
Oh.
Even if the answer is 0 feet, it's still
0 feet.
0 feet. I'm talking
Okay.
about units here. Alright.
It's
Okay.
like combining like terms.
You're so good at this.
Oh,
it's
that's
because I did that with you in chemistry. No, it's just because you're good at this.
Nah,
I don't know.
I sucked at chemistry, so.
Alright. What's the square root of meter squared per second squared?
meters per square.
Over second.
Meters over second.
Okay, so I'm going to take away that square root, I'm going to take away this.
Uh-huh.
What is a meters per second plus a meters per second? Or
Meters per second.
Meters per second.
just meters per second. It doesn't matter the plus or minus.
Divided by meters per second.
Okay, alright, there we go. There we go.
That's meters per second squared.
So I just
You're
simplified
dividing.
this thing a little bit. Is that alright? No magic. No,
yeah. You
no,
said. Yeah.
no trickery. Alright, so
Now you're dividing.
really what I have is a meters per second, which is that one right there,
Mhm.
equals, or no, times a meters per second, which is that one right there,
Over meters per second.
times second squared over meters.
Oh, it's some inverse. Yeah.
I just took this fraction.
Flipped it
What do you
over.
do with a fraction
It's
over a fraction?
reciprocal.
You take the
you
one
multiply
at the
it by
bottom,
the
you reciprocate
reciprocal.
it, you multiply it. We cool with that?
I don't know the.
So
It's basic algebra.
this second squared gets cancelled out with these guys right there, right?
It's all in meters.
This meters gets cancelled out with that meters. My units and the n is going to be
Meters.
meters. Is that a good units for a range?
Yes.
Yes. Because we're trying to find. Oh.
The units work. All right.
Yes.
Okay.
Next thing.
Oh.
So that one's slightly below your line.
I just like when everything just falls together.
What
That's
if-
cool.
It's like when you shuffle a deck of
What if
cards.
theta
and then
is
it actually-
90 degrees?
Ooh,
You're shooting up then.
you're shooting like
What is your
straight.
range equal to?
0 because you're shooting up.
If theta equals 90 degrees, our brains, our intuition tells us that r is going to be 0. You cool?
Right. Yeah.
What is
Wow.
the cosine of 90 degrees?
I can find that out if you pass me my phone.
Fine, find it out.
Well, actually, thinking physics-wise, even if you shoot directly up, doesn't it still slightly arc
No.
cratering?
Assuming there's no wind or air resistance. Actually, if there's air resistance, that wouldn't matter. But assuming there's no wind.
Yes. Unless there's like a curve.
What's the
Gravity.
cosine of 90 degrees?
cosine of 90 degrees?
This is where that paper thing my teacher gave me would be really handy.
It's in degrees. So cosine of 90. It's also 0.
Okay, so the cosine of 90. So if I plug 90 in for here,
It's
this would be V naught times 0 times a bunch of junk.
but it's still gonna be 0.
It doesn't matter what that junk is.
It's all
It's not
zero.
Because
gonna
it's
be
0.
Yeah.
Hey, the math agreed with what your intuition said.
Oh, cool. That
Right?
rarely happens.
That just means you got to get a better intuition.
Yeah.
Go down to the intuition store and go find one.
Does that make sense?
yeah.
I think that's pretty cool. Okay, what if we did this? What if we let... So did that blow your mind? Kind of? Not really.
Kinda.
What if we let H1 equal to H2?
So it's the same height.
Yes.
Um,
What would that do here? Okay, so I would have R equal... So what would that do here? Where do you see H1 and H2?
at the very end.
In the
And
quadratic.
over here you have inside the parentheses H2 minus H1. What is H2 minus H1 if H2
If they're equal,
equals
Zero.
H1?
0.
0.
So then
So
that cancels
this
out that.
term would be 0. right?
Wait,
Mhm. Oh, but then the
the
No,
whole
no,
thing is
no,
going to
no,
equal
no,
zero.
not the whole
no,
thing would be
no,
0.
no, it's not.
But-
slightly.
This stuff would still be there.
Yeah.
Okay, so let me just write this out without writing that term.
Okay.
Wait, that's right. 'cause
Is that
it's
right?
different. Thank you.
So V naught cosine theta times V naught sine theta plus or minus the square root of V naught squared sine squared theta all divided by G. Are we cool?
Yes.
Parentheses.
I think is are you forgetting attendance, Sarah? Miss Onani?
Parentheses.
Never mind. That's right. Parentheses where?
The V naught
On
cosine.
the
Oh, you want it around here?
multiplying,
Yeah.
'cause
Okay, fine.
you're not.
Can I do some chalkboard math?
Go for it.
I'm gonna take off this square root
On
because I can take off the
Yeah.
squares. Is that cool?
Yep.
Yeah.
Okay. And then I'm only really gonna consider the plus, not the minus. Would you like to know why?
Because
because
we're
you,
going in the positive direction.
No. Because if I consider the minus, it would be V naught sine theta minus V naught sine theta. That would be 0, and the whole thing would go to 0.
Oh,
Is
okay.
that right?
Yeah.
I mean, I could say, keep in mind, R equals 0 as well. There, I accounted for it. Sound good?
Yes.
This is just 2 V naught sine theta, because what is V naught sine theta plus V naught sine theta?
2 V naught.
2 times V naught sine theta. Are we cool?
Yes.
So this is V naught cosine theta times 2 V naught sine theta all divided by G. We cool?
Mhm.
Okay, so that would be 2, or here, I'm going to write it like this. V naught squared times 2 sine theta cosine theta all divided by G. All I do is I just put the 2 out in front and the V naughts I combined.
Okay.
And I put sine theta first and cosine theta. Because I like sine better than cosine. I don't know.
That's a preference thing. Okay.
And
Well,
that's
and
the
if
R.
the first one is SOHCAHTOA too.
Look in your notes. You take good notes. Look for a range equation.
Oh, did I write that one down?
Yeah, you did.
Ooh.
I know,
Isn't it
just
the basic?
where?
Is it the basic range?
And what
equation
notebook? Can you
where
pass me
it's-
the other notebook?
You have multiple notebooks that you write things down.
Yes. It's not the smartest idea.
No,
I started running out of paper.
bro, I have like 3 notebooks that have all different kinds of math and stuff in it. So it's,
Did write it down. I just don't remember in which.
Where you put it? We have to find
would
it.
it be the same range equation
February
as most
22nd. That's when
things?
you kind of went it over.
Isn't
Would it be the same range equation?
like range equals distance over time?
No.
Dang.
I guess that would be the baby range equation. No, we're talking about. We're big kids
I
now.
did just pull it up on my
I'm
phone.
a big kid now.
I remember you telling us not to memorize that equation.
Okay, fine. Look up the range equation.
The physics one, though.
Yes.
The big kid one.
Oh, I see. You take your homework notes in this as well.
Yeah.
Okay.
It's
you
r
put up-
equals v naught squared over g sine.
Sine 2 theta?
Yeah.
You said v naught squared over g times sine of 2 theta.
Yeah.
Okay.
Is that
Look
correct?
up on your iPhone or your smartphone or whatever, double angle formula trigonometry. You don't type it in, just say it or something. I don't know. Do it quickly.
Oh man, I wish I
Angle
remembered
formula.
everything.
Is it this one?
Should say something like sine of 2 theta is equal to 2 sine theta cosine theta.
Oh my god.
Right there. I
Oh.
could have written that as sine of 2 theta instead.
Hello.
So this equation in
Wonderful.
here has hidden in it, right, the range equation.
Huh.
Because we made the range equation only works when you're talking about a football player throwing a football and they're catching it at the same height that they threw it at.
Right.
When h1 equals h2.
Right.
So when we said in our general equation where h1 didn't equal h2, but then we said, I wonder if, without even solving the range equation, going back and redoing all of that junk, I wonder if I let h1 equal h2, what would happen to my equation? It would spit out the range equation.
Oh, that's pretty cool. Oh,
It's also
sweet.
Oh, snap. Okay, what other tricks can I do with this thing? Let's do this one. How about this? What if we... Okay, I'm not going to erase that because that's actually pretty cool. What if we did this? What if... So this is an if right here. This is an if right here.
Okay.
If theta equals 90, then r equals 0.
Yeah.
And that made perfect sense to us. If I shot this thing up in the air,
It's not going.
it ain't going anywhere right now. It's going to go really high up in the air, come back down.
Yeah.
Another one is if I shoot something at the same, and it lands at the same height that I shot it at, then essentially this thing is, this formula will give me this.
Yeah, it's cool.
Okay. What about this one?
It's also good
What if
gotta go through all that
theta
work just to
equals
get the same
0.
equation.
So if the angle's 0.
yeah, if theta is equal to 0
Okay.
and h2 is equal to 0. Yeah, let's do that.
Okay. What is H1 still in it?
H1 is still there.
Okay.
So
I'm going to change H1 to equal to H. I'm just going to, since I'm only dealing with one H, I don't
Yeah.
need the H2 or H1 because the
Right.
other one's 0.
Right. 0 is at the ground. Okay.
So
you're shooting.
so let's
down.
let's
plug that into this
Yeah.
equation. What is the cosine of 0?
Cosine
0.
0.
Wait.
Cosine of 90 is 0.
Cosine of 0 is.
Runs with a good friend of mine. He's in lives in Southern California.
Aston?
No, he lives in Southern California. He's
Maston's from South Carolina.
Oh,
one of my good Mexican friends. His name is
I know a lot of Mexican names. Juan?
One.
Oh,
Alright.
I was thinking Poncho. Sorry.
My
Right.
mind went to
What
Lady
number
Gaga's one.
rhymes with my friend who lives in... Oh, Pancho!
Oh, Pancho face.
Didn't think that through. Okay. So 1.
Cosine of 0 is 1. Is that offensive?
Kind of.
What?
I made it offensive. Yours didn't.
I think one is offensive.
But I actually have a friend named Juan. That's a true story.
That lives in Southern California.
Yeah.
Oh.
I went to school in Southern California, and I had a friend named,
Juan.
Okay, then it's
Juan.
not offensive.
and I also had a friend named Guillermo.
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 It was something
Most
pronounced his
likely.
Oh.
Probably
And
Guillermo.
Jorge.
Jorge.
I love Jorge.
Well, Southern
Like,
California,
I
which
actually-
you can't expect.
I was actually you know how they have the homecoming king and president, princess? I was the homecoming
King and Queen.
prince for the Society of Hispanic Professional Engineers in Southern California.
What?
Yeah, I'm an Asian.
See, I told you he was Asian.
You know
he
why?
said he's Filipino. I
It's
know.
because the Filipinos get mixed up with the Mexicans down there.
Yeah, it's because the Spanish blood
They're
makes
like,
so
wow,
well.
you're dark skinned. You must be
Be
Mexican.
Mexican.
Right.
No,
No.
there's others, you know.
I'm
Right,
Asian,
right.
yo.
So, anyway, but I was really good friends with them. They were like, "Those are my peeps, man."
Long
Cool.
story short.
Anyway,
Back to
one.
physics.
we plug that into there. So the cosine of 0 is 1. Okay, so I have r is equal to v naught times the cosine of 0, or cosine just 1.
Yeah.
Times the sine of 0. What's the sine of 0? Or v naught times the sine of 0.
This is
Would that
where
also
this
be
chart
one?
would come.
I don't think so.
No, the sine of 0 is not.
It's something else.
You guys should memorize these graphs in your head. The sine looks like this. And over here, this is 90 degrees. This is 0 degrees.
What the heck is this?
You've never seen this graph of sine?
I don't look at the graphs. I
I think I've.
had a sheet of paper
Okay.
my teacher
All right,
gave us
here,
that
this is
had
gonna
all
trip
the
you
things.
out. You ready? Here's
With
the
all
graph.
the angles.
Here's what the graph looks like. Okay, ready? So this is the sine function. And guess how high it goes?
10.
To 1.
Dang
And guess how low it goes?
Negative one?
To negative 1. It goes to 1, negative 1, 1, negative 1.
And that's sine.
But you can't.
And that's sine. Would you like to know what cosine looks like?
Sure.
Cosine looks like this.
It's like the same thing.
Almost the same thing, but
But
at
you start
0
at
it's
1.
1 and at 90 degrees it's 0.
Oh. Neat.
Alright, so the sine of 0 is what?
1.
No,
Oh,
this is the sine.
Sine of
function.
0. Oh,
Zero.
sine of 0 is 0.
So v naught times 0, I don't even need to write that.
Yeah.
Plus or minus v naught times 0.
Zero.
So I don't need to write
Squared.
that. I just still need the square root, right?
Yeah.
I've got negative 2g, that's 0. Let me write this in.
So it's
The
times
square
H.
root part, negative 2g times
H?
negative h.
Yeah.
Right.
Because h2 is 0, h1 is not 0.
Yeah.
h1 is 8. So that would basically be positive that, right?
Yep.
Divided by
G?
g. Cool?
Okay.
So that would be r is equal to v naught, the square root of 2h over g.
Could you take the computer out of the backpack and give it to me?
Alright, that's
We're cool with that?
Yeah.
Okay.
Oh,
You don't
wait,
need
that looks familiar.
Totally looks familiar.
Oh, and it's gonna bug me.
Wanna
You know what this
think.
is? Think about
Jimmy
how we
Neutron.
changed a picture. Our picture was like this, right?
Right,
We
But
set
now
this
you
guy to
made it
0.
negative.
right.
Then instead of shooting up at an angle, we shot straight like this.
What?
Right? We let
Oh, yeah.
theta equal 0.
That's right.
Oh, is that what I think
This
it
is how far your cannon will go if you shoot at a, horizontally, and it goes out a distance r. That's the equation we used. We derived this equation
Oh. Shoot.
4 weeks ago. We derived this one like 3 weeks ago. This one right here.
Come on, Elijah.
We
you
derived
should
this
go.
one today, but this one is like the master equation.
It's the one you can break into all the other. Okay.
This equation holds the key to all of these equations, and these equations are just scenarios of this very general case.
Huh.
And you know what, my friend? You would have never seen any of this had you plugged in numbers.
True.
Yeah. You would have skipped all of it.
You would have just got the smaller equation.
No, you would have just gotten a number. You would have gotten.
You would have just got a number.
You would have gotten 100 feet. Whoop-de-doo. You wouldn't have seen the elegance of it.
Oh, is that 2 delta y
That's
over
so
a?
interesting.
does a V naught come?
All right, here. You want to know where this equation comes from?
Yeah, I remember I wrote it.
Look,
I just
remember,
Let's
it's
go
'cause
back to
V
pretend.
cosine-
We didn't understand anything about here.
Okay.
Let's go back to just solving this problem. I shoot a ball horizontally, a velocity initial v naught. How long does it take to fall? Well, h, right? Because that's my delta x equals v naught t, but v naught in the y direction is what?
0.
0. So 1/2
Oh,
gt squared.
you did this on the. What happens if you jump off the waterfall? How far would the rocks be?
Yeah, there we go.
Yeah, I remember now.
So
Just think-
in order to solve for t, you just go 2 over here, g
Divide by
downstairs, square root
the
it.
whole thing.
That's where that comes from.
Oh, cool! I do remember. Okay, sweet. That's good. That's good science.
Then this is saying your distance is your velocity times your time,
Oh, cool.
which is actually what you said here. Distance is velocity times time.
Oh, this is cool.
That's like the range, the baby range.
This is the baby range equation.
Yeah.
This is the
This is the
Range
physics
equation
version
that
of
you
the
would-
baby range.
this is the range equation that you would do if you threw something horizontally. In the very specific scenario that you were firing horizontally or throwing a rock horizontally or running and jumping off of a cliff horizontally. The very specific scenario of that
Is that equation?
is that equation. But here's the very general scenario. And this holds all the other pictures inside of it.
No, leave that there.
Hey, you want to apply that to that very specific situation? Well, I'll just make theta equal to 0.
And
And I'll make h2 equal to 0. Done.
no, that's cool.
You want to figure out the range equation? Oh, okay, fine. I'll just make h1 equal to h2. Done.
Cool.
I don't need to solve another problem. I don't need to redo this. And I think that this is the power of this thing, which
Yeah.
makes it so mind-blowingly freaking awesome.
Write this down. Call it the master equation. That'll be cool.
Don't memorize the master equation either.
Oh, okay.
I'm just letting you know.
Neat.
I never memorize this equation. I don't memorize these equations.
Oh, but if you know the thought process to get
I
to
memorize delta x equals v naught t plus 1/2 at squared.
them. Shut up! No.
I memorize
Perfect.
one equation. Delta x equals v naught. That's all of this. All of this
From that equation.
came from that one equation. Delta x equals v naught t plus 1/2 at
Oh,
squared.
that's really cool.
This is like the physics
But
version.
you can stay here.
This is the
This is the physics version of perfect.
right. The delta x is the
And Samantha
Neat.
stay and work on her
Yeah.
project for a little bit.
yeah.
What time are you leaving?
What time you gonna leave?
I'm leaving right now.
No, what time does she need to leave? I can leave then.
Well, I mean, whenever you leave, she can leave.
I'll be here at 4. Anyway, I hope that I thoroughly messed with your mind.
That was cool.
Yeah, I enjoyed it a lot too. But you want to know something really cool?
Mhm.
Is that like now that you've solved it using variables and
Is
you've
it gonna be
solved the
so
hard
much
version,
Easier.
You can just.
I can't give you a hard problem now
Oh,
It's
cool.
gonna be so easy to
because
solve it
every
with
other
numbers.
problem that I give you will just be almost when it comes to projectiles.
Yeah.
Would just be a variation of this using
Oh.
different numbers.
Sweet. So
But you solved it for without using any numbers, so you can solve
anything.
Right.
Oh,
So
cool.
so that just made all of the 3-star problems and the 2-star problems and the 1-star problems the same problems.
Oh, just
Same level.
Do you get it? Like, I can't
when it comes to
in this chapter I can't really give you anything more complicated than this
that's a confidence boost. Okay.
because anything that I give you is really just going to be variations on this.
Now all you have to master is trig.
Oh, that's good.
I like trig.
I'm actually
Trig is nice. It's
pretty
nice.
excited for that Canon midterm or what's it called lab that we're gonna do eventually.
Yes, I don't think we're going to do it in quarter 3. I think we'll do it at the beginning of quarter 4 or the middle of quarter 4.
Question: can this be applied to that basketball one you're talking about?
Absolutely.
The one
Sweet.
The one we had for our algebra final?
Yep.
Where we're not in physics?
Yep.
Physics!
You know what? You want to know why this applies to your algebra final and I gave it to you as an algebra final, not in physics, even though it's this complicated? It's because
What did we use to get
the
here?
quadratic equation.
The quadratic equation.
This
In algebra, all we were doing was matching parabolas. Well, what does physics do?
parabolas.
It's
dealing with
Parabolas.
Well,
I love it.
I still remember when you told us the
Bye,
quadratic
Anya.
equation. You're gonna use this like every day in physics. Bye.
I'll see you tomorrow.
Yeah. Oh
No,
yeah.
no, you won't. You're not. You don't use it every day. You just use it for the hard problems.
Right. Which is pretty handy. Because at least we now have bazooka. I wonder what the fly swatter looks like.
Well, the fly swatter looks like if I were to mess with these numbers, so that way this ends up becoming like pretty numbers. But do you see how like very rare that would be the case?
Yeah.
When will I calculate all of this and it ends up being 5?
Never.
Almost never, because
Yeah.
you're dealing with 9.81, you're dealing with the sine of a number, you're dealing with the sine squared of a number, and then the square root of this thing minus this thing. It's like very rare will you get a situation where you get this pretty equation that this thing comes out to 2.
And it just. Oh yeah.
You see what I mean?
Yeah.
So that's why the quadratic equation is so much more powerful, because when you apply it to real life, when you apply it to the kiddie problems we make up in math to make all the numbers pretty for you to deal with, then you'll use your fly swatter. But if you apply it to actual real life things, 9.81,
Right. You want the bazooka to make sure you're not wrong.
well, you want the bazooka because the fly swatter almost never works.
Oh.
With real life numbers? Are you kidding me? When you plug in this V naught, this stuff, and you actually end up calculating it all out and it comes out 2, I don't think I've ever actually even seen a situation like that.
Oh. Cool.
So anyway, this is your answer.
Sweet.
I love this answer.
Yeah, that was cool. Oh, this is gonna be cool.
So that pretty much covers the hardest problem in
Two-dimensional motion.
two-dimensional motion. I don't even think that. I think high schoolers solve this. They don't use variables all the way through. That's for sure.
Variables comes in handy because then you can just change whatever you need.
Right. And I mean, here's another thing that's really interesting to me is, you know, whenever I see a square root,
Yeah.
over here, and I see a negative square root, I think there's a possibility that this could be, this thing right here could be a negative number. In which case, this would be an imaginary number. In which case, you don't actually have a range that you could solve. Why do you think that would be? How does that, like, that's kind of an abstract, the imaginary number is kind of an abstract concept. How does this relate to the physical problem we were solving?
Not sure. Maybe.
Okay, well, you actually know it. You have the intuition for it. I'll show you. You understand this. Really, the big concern about this being negative, the stuff inside the square root being negative, is that h2 minus h1 is a really big number. Right?
Right.
Because if h2 minus h1 times g times 2 is bigger than this, then that would be a negative inside the square root, right?
Yeah.
What it's saying is, if your cliff is too tall,
You're not gonna hit the target.
that thing won't ever hit the target.
Oh.
Because maybe you're going like this.
Oh, you're gonna hit. Oh, cool. Okay. So. Huh.
So this could actually even be, you can even go back and answer a question like, what is the tallest cliff I could use in order to, for this, you know, what is the tallest cliff I could possibly hit? And your answer would be, well, the tallest cliff you could hit is to make this number 0.
Yeah. Because anything more. If you make it lower, then it's gonna be.
Because then your range would just get up to that thing.
Oh, cool.
So the tallest. So then basically you just take this equation, the smaller equation, set it equal to 0, and you can figure out what h2 is relative to h1 is. That you can actually hit this thing. Anything bigger than that, any bigger h2 relative to your h1, you won't be able to hit.
Yeah.
It's be impossible because you have a negative. So this even this abstract math thing makes perfect sense in the real world. And if I told you the cliff is too darn tall, how far is this going to go out before you
Oh, cool.
hit? You won't.
Yeah. Oh, that's neat. Huh.
So even abstract math is
Can be used in physics.
yeah. What about the negative range? Because this would be a positive range, right?
Right.
That's what we saw for. But what about the negative number? What is that?
That'd be if you're shooting down?
No, here's what including this negative sign, because a lot of people will just get rid of that negative sign,
Right.
because there's no such thing as a negative range.
Right.
Right?
You'd be going backwards.
Well, what it's saying here, and this is what your physics is saying to you, is if this is the parabola,
Mhm.
then if I were to continue this, then what it would do is I'm setting that equal to the height, then the minus sign would actually give me this range as well. You would have two ranges, this range and this range. Because what you're saying is, dear Mr. Physics, what range gives me a height of that? And the answer is, well, I'm going to include this plus or minus because there's two ranges that will give you this one and this one. One when you're going up and one when you're going down.
Oh. So it's 2 point. Okay. So it's like the.
So it's taking into account those two spots.
Oh, yeah, I remember that from the. Oh. Starting to make connections.
There's just what I'm saying here is there's so much you can do when you solve things in variables. And I've been trying to convince you guys that that's the best idea this whole time. But really when you look at this, like, this thing is super powerful.
Be used in almost, well, so far 4 different ways. I'm sure there's more.
Yeah. I'm going to solve a problem with you later on, probably tomorrow.
Cool.
That is going to do something like this thing. And it's going to be like, wow, that's really interesting. But really, I can't really give you,
Any hard questions now? Or, well,
for your, like, if you want to set up a war thing,
Mhm.
then I would actually tell you, you would calculate out the velocity of your cannon, absolutely. And I would tell you the range and the H2s and the H1s and the, gravity.
Yeah.
So then you would be able to calculate out the angle, or at least make a table of what angle you need to shoot at in order to hit that thing.
it's pretty cool.
Does that make sense? And I need to show you how to make a table for this, because to actually solve for theta,
Mhm.
that's really difficult.
Okay.
And I wouldn't make you do that.
If you teach me how to use Excel, that'd be awesome.
But I'll teach you how to use Excel.
Or not spreadsheets so far.
Well, it's spreadsheets or Excel, either one. They're just as powerful.
Neat.
All right. Have fun.
Thank you, Mr. Dolly.
Yeah, I enjoy physics for this reason.